Well, an early hello to all of you who have already logged in and are having a conversation on the side. Welcome to our 2022 DRIFCan fundraiser, an evening with Dr. James Shapiro, and a diabetes research update. As I look at the numbers, they're well over 100 already. For many of you who have been on the broadcast, I noticed since about 20 minutes to 6. And on that note, I want to welcome each and every one of you. We're just going to chat for a little bit before we start our formal program, and welcome those of you who are joining. If you're just logging in, give StreamYard. That is a software that allows us to broadcast tonight. Permission to use your name, introduce yourself, and let us know where you were joining from. Vincent Weiss was the first one who said hello, and he says, hello, is anyone there? Vincent is joining us from Ukraine. And so welcome to you, Vincent. It is nice to have you with us tonight. We appreciate you joining us. Also, we have Leah Weeb from Canada. Hello to Leah. Alexa Channel, hello from New York City. So many of you that are joining our broadcast from right around the world. I want to make sure to say hello to as many of you as possible. There's Alexa from New York City. Art forms, illustration, and graphic design is in Edmonton joining us, as well as Nikki. She says, you're so happy to see people from all over attending. I'm from Edmonton. Thank you, Nikki. I feel exactly the same way. Dana Bovin is joining us from Edmonton, a type 1 diabetic for 22 years. Lisa is joining us and says hello from Michigan. Jessica joining us from rural Alberta. She says, I'm in Toefield type 1 for 33 and a half years. I love the conversations that are already taking place from so many of you. Eleanor Clark is with us tonight. Lisa says she's been type 1 since 1970. Andre joining us saying hello from Edmonton. Lindsay, Executive Director, Alberta Diabetes Foundation, Executive Director, joining us. Eleanor Clark, how is the weather where you are? She's joining us from the beautiful island of Barbados, West Indies. I'm sure your weather, Eleanor, is a lot different than what we're seeing today in Edmonton. For those of you in Edmonton and Calgary joining us, we welcomed winter this morning with a huge dump of snow. So, Eleanor, I'm sure that you're not seeing any of what we're seeing tonight. As Maureen says, I want to be where Eleanor is, snowing here in Edmonton. Yes, that is so true. Noah is joining us from the beautiful Palm Springs area. Jason from Humboldt, Saskatchewan. Martine says hello from Calgary, Alberta. We have Steve Marks, who's joining us from 1,000 Oaks, California. Hello to you. Mark McKay joining us from Invermere, BC. Raju from Calgary. Sandra joining us from the Niagara region in Ontario, Canada. Tammy Brown from Edmonton. Hello to Lindsay from St. Catharines, Ontario. The Highlander Law Group joining us from Nova Scotia tonight. Rena is from High River, and she says that she was wishing she's in Florida or Bahamas right now. I don't blame you, Rena, one bit. Diane says hello from Toronto. Gabriella says, I am from Oakville, Ontario. Rebecca from Richmond Hill. To each and every one of you joining us this evening, we have Kay Max joining us from the Washington, D.C. area. Calmar, Canmore, my goodness, I want to say a warm welcome to each and every one of you, taking time out of your evening tonight to spend it with us in such an important fundraiser for DRIFCan. We really have a powerful evening planned for you. I wanted to take some time and welcome all of you who are joining us really from around the globe. And I want to stress right at the beginning that tonight is a conversation. This is an opportunity to connect with world-renowned diabetes researcher, Dr. James Shapiro, along with his clinical team and his research team. Yes, you are going to meet everybody who is involved in this groundbreaking research. This is such a rare opportunity because it just doesn't happen where you have the opportunity to ask them questions tonight. So I really we want to encourage your questions and conversation tonight. I mean, as a host, I can sit and ask questions all day, but this is for you. This is for you to learn and to understand the groundbreaking research that's happening and how close we are getting to a cure. Strides are being made, and you can be part of the story. And we are going to dig into all of it tonight. So keep your comments coming. I'm going to do as best as I can to keep up with them and to bring them into the conversation. So please be patient with me, but do take that time to ask questions, introduce yourselves, and let us know where you are joining us from. In the interest of time, I see it is now 6 o'clock. I want to keep our program on schedule and be respectful of your time. So in that spirit, I say hello to each and every one of you, ladies and gentlemen, researchers and scientists, patients, families, friends joining us from around the globe. Hello and welcome to our third annual virtual fundraiser, An Evening with Dr. James Shapiro, a diabetes research update. As I just alluded to, tonight is an exciting evening and opportunity for all of you who have joined us for our annual fundraiser, because it truly is very rare to have direct access to a world-renowned diabetes researcher, Dr. James Shapiro, along with his clinical team and his research team. They're all waiting in the green room. They're all going to talk to you tonight. This is your chance to ask questions of them tonight. And so that's what I mean when I say direct access. How often do you get an opportunity to sit with someone? And when we're virtual, it is kind of intimate because you feel like you're actually talking with them and ask your questions. You ask them and I'll bring them to the researchers and to the team on your behalf. So exciting. And we are going to dive into all of that in a moment. I just want to take a brief moment and introduce myself. I know many of you, you know me. I'm Carrie Dahl. I was a longtime television news anchor and a medical reporter turned podcast host and public speaking coach. It truly is an honor to serve as your MC for tonight's virtual event. You know, over the years, I have to say I had the opportunity and the pleasure of interviewing Dr. James Shapiro many, many times and following his work with so much pride as an Edmontonian to know that we have such a world-renowned researcher right in our backyard. I can't help but to want to be part of his story and to follow it and to share it with the world. And, you know, oftentimes when I was reporting, I had the likes of CNN calling me up at my network and saying, please, Carrie, we need an interview with Dr. Shapiro. And that was before the days of, you know, technology like this that made it easy and FaceTime to do interviews. So I used to do a lot of interviews for ABC News and CNN and send them off to them so they could share Dr. Shapiro's work with the rest of the world, because so many people are interested in it tonight. So that opportunity was a rare one for me. And now I want to share that access with you tonight. And if you're just joining our broadcast right now, I can see the numbers going up by the second. So many of you watching tonight. Go ahead, introduce yourself. Let us know where you're joining us from. And then on the bottom of the screen, you can see a chat box where you can write your questions. And I will be checking them as much as possible throughout the broadcast. So tonight, as I mentioned, is all in support of Diabetes Research Institute Foundation of Canada. More commonly known, you'll hear us refer to it tonight as DRIFCan. And as I mentioned, we appreciate the time you are all taking out of your busy lives to spend with us tonight to learn more about DRIFCan along with Dr. Shapiro's work. And of course, help us raise funds for his research to accelerate a cure for diabetes. I do want to stress something right off the top of this broadcast that is so important about DRIFCan. Do you know that 90% of the money that is raised goes directly to fund Dr. Shapiro's research? So with that number, you know that administration costs are extremely low. So you can be confident that your contribution tonight can and will make a difference in helping Dr. Shapiro's research. So that's very exciting. Also keep this in mind tonight. When you make a donation, no matter where you are joining us from, that donation can be made in the currency of the country that you live in. So you will have the ability to select the currency. There's a button right there when you go to make a donation, and you will also get a tax receipt for your donation. We're making it very, very easy to donate tonight. All you have to do is visit the website, www.DRIFCan.com. There are also many other ways that you can connect with DRIFCan, whether it be on Twitter. There is the handle that you want to look for. You can also follow them on Facebook as well. They are available on Instagram as well. And they are also on LinkedIn, and I will get those up for you as soon as I can find them. But bottom line, if you are making a donation tonight, you want to go to www.drifcan.com. So, as I mentioned as well, I want to leave you with this thought tonight and plant it early tonight. Yes, tonight is a fundraiser. We will be asking for your donations, as I just mentioned. But I want you to think of your donation in this way. By making a donation, you are becoming part of this story, part of the solution, and part of the eventual cure. And Dr. James Shapiro and his teams are so, so close. So just think about this. A few years from now, whenever that cure is announced, or who knows, it may be even sooner than that time frame, you can tell your family and your friends or your children or your grandchildren that you made a difference. You helped fund the researcher and the team that found a cure for diabetes. Now, that's a story that lives on in infamy, and it will be told around the dinner table for years and years to come. That story will never, ever get old. So it's a little food for thought as you contemplate what donation you want to make tonight, because that donation, as I said, is your ability to take ownership of this story, to be part of the narrative, to make a difference in millions of lives around the world. As I mentioned a few times as well tonight, we want this event to be informative and as interactive as possible. So as I said, get involved in this conversation. I know that many of you joining us tonight know each other. You may be colleagues, you may be friends, but being able to ask questions in real time of this team is a really special opportunity. It's unique. All you have to do is type them in the chat box and I will read them as I'm going through the event. And I just want to say thank you in advance to all of you who are participating tonight. So the format for tonight is quite simple. Over the next 90 minutes, I will begin by giving you a little bit of background about DRIFCan. Melanie Hibbard will be joining me momentarily, and many of you know her or you have heard her voice over the phone and dealt with her when you're inquiring about DRIFCan. She is their only administrative assistant, and she knows everything there is to know about the organization and how it works. But Melanie doesn't just work for DRIFCan. She lives it. And what I mean by that is she has 2 sons who are living with type 1 diabetes. And believe me when I say she wants a cure so bad. And she's going to talk about that in a little bit. After chatting with Melanie, we're going to have a brief conversation with Rob Otway. He's the chair of the DRIFCan board. He is going to explain a bit tonight about the why of the funds raised and what they're needed for and how they're used by Dr. James Shapiro and his team. And he will talk briefly about some of the goals of the organization and how change takes time. It really does. Then the rest of our evening will be spent interviewing Dr. James Shapiro about his work, the exciting new steps forward that his research team and his clinical teams are making, the progress being made, and really why it is so important to play the long game in research. For those of you in business, you are well versed in the long game. Success in business or in medicine, it just takes time. And playing that long game truly does pay off. You're going to hear more about that in a minute. After my interview with Dr. Shapiro, we're going to move right into the lab in Edmonton. Yes, I have his clinical team and his research team that are waiting in the virtual green room right now. You're going to meet all of them. And they're going to explain in terms that you can understand as simply as possible what they're doing and why their role is so critical to the research. And such a rare opportunity to have access to these types of people doing this research. So I encourage you to listen and ask questions along the way. And we will wrap up our evening tonight at 7:30. So with that, let's begin with more information about DRIFCan. Their mission is laser focused on accelerating the cure for diabetes by directly funding diabetes researcher Dr. James Shapiro and his team at the University of Alberta. So why is this so important? Well, here's a few statistics and the numbers regarding diabetes. In Alberta, over 1.2 million people live with a form of diabetes. That is 27% of our population. The cost to our healthcare system is getting close to $500 million a year. In Canada, over 11 million people live with some form of diabetes. That number goes up to 28% of the population, and the cost to the healthcare system, a staggering $14 billion a year. When we look at the numbers around the globe, they grow to over 460 million people living with some form of diabetes. And then keep in mind, this is the big point, the government does not fund this type of research. So that's why fundraising like tonight is so crucial to see our advances continue to move forward toward a cure. A few other tidbits I'd like to pass on tonight. November is Diabetes Awareness Month. Blue is the color of diabetes if you would like to support, so wear your blue this month. Here now to lend perspective on this conversation and how and why your dollars can make a difference is just an amazing woman, an incredible mother, and a wonderful human being. Such a pleasure to welcome a familiar face and a voice to many of you. Join me in saying hello to Melanie Hibbert, who is the Executive Director of DRIFCan, the Diabetes Research of Canada, and of course, mother of two boys living with diabetes. It's so nice to see you, Melanie.
Hello, thank you very much. Great to be here.
I know that many people who are watching tonight probably recognize your voice, but you likely haven't met a lot of them in person.
No, that's correct. I mean, it's been great. I mean, COVID did lend us Zoom. So I have met a lot of people around the globe that I wouldn't have normally met, but you're right. Usually it's by telephone. And I'm watching the comments on the side, and it's pretty exciting because I'm seeing a lot of names that I've seen through the last few years on all of our social media and contacting me directly. And so welcome to everybody.
Wow.
I'm so happy that you're all here.
Maybe what I'll do is while we're chatting is I'll bring up some of the comments and some of the names, and so that we can make sure to bring them into the conversation. But I want to begin here, Melanie. I said, this is important to you personally and professionally because you have two boys that have struggled for years. So tell us a bit more about that.
Right. I have two kids, so I'm here. I'm in it. This is, I live it every day. So I have a 23-year-old son who was diagnosed at the age of 4. And then 15 months later, my 18-month-old Travis was diagnosed, and he's now 19. So we're coming up to 19 years dealing with the disease, and it sucks. So there's no other way. They're well controlled. They have great treatments. They both, wear a pump. They wear a Libre. But at the end of the day, it's not a cure. And so that's where my focus changed about 7 years ago when I got involved with DRIFCan, because I knew that, there's great organizations, but we don't need to fund the treatments anymore. We need to fund the cure. And I know where it's at. I've been, following Dr. Shapiro for 19 years, heard him speak so many times. And when I was given the opportunity to come and be with DRIFCan as the executive director, it was a no-brainer for me because I knew we needed to stay laser focused on what was happening. So a lot of people ask me that question, like, why are you doing this? Or why are you here? If I didn't believe in it, I wouldn't be here. So that's the simple thing for me to say, is that I believe in this wholeheartedly.
So yes, you do believe in it, and you believe in Dr. Shapiro and his team, and you've been following it for years, and the progress is staggering over that time.
Oh, it's crazy. Like, I'm so excited because for many there's all these steps. You start with the Petri dish, and then you move to, and I'm simplifying it, but you start with the Petri dish, and then, you move to mice, and then, it's always that, when are we getting to the human trials? And that's going to
Mhm.
take time. And so for the human trials, the one thing that a lot of people don't realize is that Dr. Shapiro is one of the fastest researchers to get Health Canada approval for a human trial. One of his last trials moved in less than 12 months to human trials. And that's amazing. So when you have a track record like that, it's just a no-brainer for me
It
where
really
we need
is.
to support and what we need to do and how fast it's moving.
Look at the question for you on the screen, Melanie. They want to know how you got involved with James Shapiro. Was it the Edmonton Protocol?
Well, definitely, I knew about the Edmonton Protocol and had followed it since my kids were very young. How I got involved was I did donate for many, or volunteer and donate for many years through other organizations. But again, I really wanted to stay focused, and I really wanted the funds to go where they needed to go.
Mhm.
That is very important to me. And so, like you mentioned, Carrie, I knew that our goal with DRIFCan was to be a 90-10, where 90% of our dollars raised go directly to cure-based research.
And that's very rare. You don't
It
hear
is.
about a lot of fundraising that works that way. There's usually a lot of overhead, but why not with DRIFCan?
Because we stay laser focused on what we need to do. And we have a task at hand, and it's to get as much money into the hands of the team that can make a difference and find a cure. And it's not easy. Everything we do, we say, can we do this? We're not an event-based organization. Events cost a lot of money. So we're really happy to do something like this virtually because, being able to do it like this, we don't have to have a room rental. We don't have to do all these things. So we can put the money right to the research. So I got introduced to Dr. Shapiro, heard him speak, and just knew this is where I needed to be.
There's a question here. It says, I think diabetes with children has to be one of the most difficult situations. You can speak to that.
Well, I'd give anything to take it away from them. So I think every parent that's on this event tonight would say that when they heard the words, life as you know it has changed forever, your child has type 1 diabetes, it's a gut punch. And in one moment, I would have said, no, switch. I will take it. Please take it away from them. And so everything in my fiber says, I got to find a cure for these kids.
This is a nice comment from Heather McKinney. Says, no more treatment. Let's put all funding towards cure research.
Hi, Heather. Now, Heather, I have met. Heather is in the United States, and two mamas for type 1 diabetes.
Oh, wow.
We did connect on Zoom. So thanks, Heather. You're right. I agree. Let's do this.
And Kathleen says, this is beautiful. It speaks to you. We're so glad that you're the face of DRIFCan.
Oh, thanks, Kathleen.
And so let's close with this. What is the most important thing that you want people to know about Dr. Shapiro's research?
I want you to know it's real. I want you to know that it's moving forward. This is not a pipe dream. This is not a pie in the sky that's not happening. It's happening. It's happening here in Edmonton, and it's happening every day. And so I think the most important thing that I want people to know is believe it, trust it. And if you have any questions or you ever want to know what's happening, we hopefully will continue this event, which I think is spectacular because it does give people the opportunity that don't live in Edmonton to really have this opportunity to hear from him and his team. I'm super excited because I have not met the whole team. Because of COVID, lots of things have changed and we haven't been able to be in the lab. So I'm really excited to see this and hear this. And I'm really excited for people like Heather and other people that are watching this from the United States or other places in the world, that you get this opportunity to hear from the person that I really do believe he and his team are going to find a cure for diabetes.
I have to squeeze this in too, because you have so many investor meetings where you do talk about, I've been talking about playing the long game and equating, research to business. But the bottom line here is research takes time. But as I mentioned, ultimately with donations tonight, people can be part of this history.
Absolutely. We can have something like this that'll make a difference at the end of the day. A big celebration says we were all a part of it. And, it is a story. And I often say to people, if I had to be a part of a community of people, nobody wants to be in the diabetes club. Nobody wants to be in this club. But if I have to be a part of a club, it's a tremendous community of people and we can make a difference. And I think that's what we have to do. The only way we can do that, people say, when is this going to happen? It doesn't happen without support. And so that's the biggest thing, is that we have to support this and get us to the finish line.
Yes. Just like this comment from Rebecca, will our children ever see the cure?
We will.
Yes, and I believe it as well. You are such a joy to have around, and with everything that you are living through, you're a living, breathing example with your boys and your family about why this research is important. I know the ups and downs you've gone through with them as they battle diabetes, and you are a perfect example of why a cure is needed. Thank you for everything that you do for DRIFCan, for being the face and the voice, the support you give Dr. Shapiro and his team, and for being relentless in your mission. You're a game changer.
Thank you, Carrie. And thank you for tonight. I really appreciate it.
And that website, say it again for everybody. Tell everybody how they can donate, Melanie.
www.DRIFCan.com.
Is there any other ways before I wrap up with you?
Actually, when you go on our website, you can click the ways to give, and there's lots of ways. You have an old car, you want to donate a car, you want to donate your bottles. There's lots of ways to give. So it's all on our website, and we accept donations from everywhere in the world.
Okay, Melanie, thank you. Thank you so
Thank you.
much. Thanks for joining us tonight. Look at this comment. This is so beautiful. Thanks so much for everything you do, says Heather McKinney. And there was another one I have to get. How about this? I know Dr. Shapiro can see this in the green room. Then Humboldt and area, I think it's T1D team is 100% behind you, Dr. Shapiro. So he's smiling in the green room. You're going to hear from him momentarily. Isn't Melanie a joy? She is just, she puts her heart and soul into DRIFCan, and she believes in it so much, as you could probably, her energy and her passion for it is palpable. There is someone else who feels exactly the same way about the organization, and I want to introduce that person now. So for further perspective on the research and how we can get this to a point where we can call it a cure, I'm thrilled to welcome Rob Otway to the broadcast. He is the chair of the DRIFCan board and executive vice president of Bird Construction. Pardon me. Hello, Rob. It's nice to have you with us this evening.
Hi, Carrie. It's a pleasure to be here.
You have a great team working with Melanie and beyond. She gave some pretty powerful perspective of how administration costs are low, and everything that is raised is pretty much put into Dr. James Shapiro's research. We need to emphasize that tonight, don't we?
Yeah, I think it's one of those things that I think over time, as you donate to various charitable organizations, you initially donate out of whether it's a personal connection or an emotional response, things like that. You don't really give much attention to what happens to your money once you donate to it. And over time, you start to realize that some organizations are more efficient than others. And I think we've made it a very laser focus, as Melanie said, to funnel as much of the money through to the researchers as possible. And essentially, it's a small amount of money that's held back for running the operation, for paying for salary for Melanie, and some promotional things such as tonight. But it's pretty mean, because we need to funnel everything to the research team so that they can hire people, buy equipment. As you said before, and I see some of the comments here, it's an expensive game to be in. Even though the cost of the system, I saw someone saying, why doesn't the government fund?
I was going to ask you about that. Yes. So go ahead.
It's one of those questions I asked. It was just, why wouldn't they? Because of the cost of the system. But if you think about that, there's numerous researchers and research groups out there, not only just in Canada, but across the world. But if we're talking about the Canadian context, from a government perspective, think about it like a startup. We are a startup. We need to prove that what we're doing, there's some legs to it, that there's this, it's beyond theoretical, that this actually could happen. And I think once we show a proof of concept that this works through human trials, the governments will definitely jump in and fund. But for now, they're very conservative. There's, in reality, there's probably some politics. They don't want to back, kind of things that may not work out, and maybe they don't look good. But it is a bit perplexing. So we really have to lean on individuals. There's tremendous grassroots support for this. Obviously, the diabetes community. There's a number of people that are very well-to-do in industry that have diabetes either directly or part of their family. They're big supporters. And it really is a collective effort, I think, at the end of the day. And
It is, and that
yeah,
collective effort, as we've been talking about, and you know this in business, Rob, it takes time.
it does.
So
It
talk
does.
about that.
It does. One of the things we've talked about in the green room before, how did I get involved with it? Part of it was by chance, just through a connection, but also was part of it through in industry. We go to lots of fundraisers, and after a number of years, when you go to similar things and say, wait a minute, like 5 years ago we talked, they said the same message, and it doesn't feel like we're moving along. I wanted to be involved with a group that was actually making a difference, and
Mm,
and each year we were making progress, and it was about finding a cure. A treatment is super important. Don't get me wrong. When you're living with a particular disease, you need treatment for that. But we need to get out of the cycle of treatment and get into
yes.
a cure. And hopefully one day this will be just something we read about, that happened 50 years ago or 20 years ago or 100
Hmm.
years ago, right? So I'm putting my efforts to help the group. The board is helping that, and to help Melanie and the broader people that help us and support us to help raise money to move this along, because we have to. We have no, otherwise we'll always be in a treatment mode. And there's great treatment out there, but I think we really do have the opportunity to get in and actually cure this thing and put it into the history books.
Look at this comment here. I think that the Tammy wasn't trying to say, instead of gifts for Christmas, I want donations to DRIFCan.
Wow, we all like Christmas gifts. Maybe a few less. But yes, that
I
would
like
be
it, Tammy.
wonderful.
I like it.
And I also want to say that I recognize that many of the people on here have already been contributors, whether through money or through fundraising efforts, or just for the broader community. I think
Mhm.
as much as anything else, can we spread the message to others that don't know about Dr. Shapiro and his research, about DRIFCan, or about diabetes in general. And I
Mhm.
think the more that we build this big spider web of connections and people that start to get to know what this is all about, we will then eventually connect to people that have, the means to help us move faster than we are currently going right now.
There is the comments are coming up so quickly. Here is on that note, Rob, it says, Steve Marks, questions about collaboration. Does DRIFCan actively collaborate and share data with other organizations around the world involved in research? And if not, what is the reason? Can you speak to that?
Well, I can speak to it to a certain degree with limited knowledge. We are so there is another organization in the United States called DRIF,
Mm-hmm.
and this organization is kind of spun out of it from my understanding of history, and they're based in Miami. And so yes, Dr. Shapiro is and our organization are actively collaborating with them. There are some private organizations like the Anna's Dream Foundation in Montreal that we're collaborating with. I think, where we DRIFCan is really a startup in a lot of ways too. So for the first 5 years or so, Melanie was working, just trying to keep the lights on, get a few money. And as we grow, we're starting to reach out and make connections from mainly in North America for now, but we're starting to go beyond that,
Mm-hmm.
because I mean, diabetes is a worldwide, uh, you know, affliction, and there's people from around the world that want to help. But we're a very small organization. It takes time, but we are collaborating absolutely as much as
Mm-hmm.
possible, given the resources we have. That's why we need help too. Obviously we need dollars, but we also need people that are in other geographic locations that can help us and connect to their communities, and so that we become much of a broader community for sure.
Some great perspective. We appreciate all that you do. And I always say it's so interesting that you don't have a personal connection or a genetic connection at all to diabetes. You just so strongly believe in what Dr. Shapiro and his team are doing. And one day we're going to be doing this and talking about the cure that
Yeah,
is. We're going to get there. It's just, you look at the progress that's been made over the years and it's astounding. They've come a
yeah,
long way. There's still work to do.
yeah. I am just very, very humbled to be a part of this and contribute in a small way, and just want to say thank you to everybody that's on this call tonight. and appreciate the personal fight and the support that you provide us as a whole. So, and thank you, Carrie, for all of your
Oh,
support as well.
you know what? As you just said, I'm humbled to be involved and grateful to just watch along the sidelines as Dr. Shapiro and his team work their magic, and they just stretch science to the limit. And I love being and just reporting on the story because it's a big
Yep.
one. It really
Yeah.
is. Thank you for
Totally
all
right.
you do, and thank you for joining us tonight. I appreciate your time, Rob. Nice to see you.
Thank you, Carrie. Always a pleasure.
All right, that's Rob Otway, who is the chair of the board, offering some perspective tonight. And such great perspective, saying how far DRIFCan has come over the years. And that's an example of how changes are made. Sometimes it feels like, research could be moving along on a snail's pace. But when you look back, even 5 years, and I know Dr. Shapiro could speak to this, there's been tremendous progress. 5 years is not a lot of time. And so we're going to dig into that. And before we introduce our guest of honor tonight, again, I'm going to remind you that www.drifcan.com is where you can make your donation in any currency that you choose to, wherever you live. And as we mentioned, almost every single dollar goes to support the amazing work of Dr. James Shapiro. So friends, this year actually marks, we talked about this last year, but this year marks 101 years since the discovery of insulin by a group of Canadian researchers, Banting and Best, along with Dr. James Collip, who was part of the team and did come from the University of Alberta. So just to be clear, the U of A has had world-renowned researchers in diabetes since insulin was discovered. And now we can be part of the discovery of the cure. And let me just say this. I do believe, as I just mentioned to Rob, that Dr. Shapiro and his team will accomplish that. They are so close. His research and that of his amazing team is changing and impacting lives right around the world. So before we say hello to him, a little bit more about Dr. James Shapiro. He was born in Leeds, England. Son of a family doctor, he studied medicine in Newcastle, trained in surgery in Bristol, and developed an interest, in islet transplantation as a medical student. He has been on faculty at the U of A since 1998, where he now holds the Canada Research Chair in Transplantation Surgery and Regenerative Medicine. He directs the Living Donor, Liver Transplant, and the Islet Transplant programs in Edmonton. He was the lead investigator on the famous Edmonton Protocol cell transplant treatment for diabetes. He is the Project One lead for the CNTRP, which is actively researching ex vivo organ transplant repair. Back in 2015, his team began the first in-human trials with embryonic stem cell-derived insulin-producing cells transplanted in an immune isolation device. What does all of this mean? We're going to ask him. We're going to ask him all the questions. He's so great with questions. I know this firsthand because as I mentioned, I've known him for well over 20 years. And as a former television news anchor, I've had the opportunity to interview him many, many times on his incredible work and his breakthroughs. And I know there's going to be future interviews with him. So without further ado, I am so honored and thrilled to welcome our guest of honor tonight, Dr. James Shapiro. It is so nice to see you.
You too, Carrie. Thank you. I'm humbled and touched and quite emotional by all the words that have been spoken tonight by you, by Rob, by Melanie, and by so many people across the world so keen on us accelerating that cure for diabetes. We have to make that happen. We have to hold true and just make this research, get it across the finish line. We can do that.
Of course you can. And I love the fact that you say you were humbled after how many years doing this, and it still touches you in that way.
Well, you mentioned my work as a medical student in Newcastle in England. That was 39 years ago. So I've been at this a while. And, it's a dog with a bone that I'm not going to let go until we get there.
If we look back on the years, I began with 101 years since the discovery of insulin. What, in your opinion, Dr. Shapiro, do you think were the biggest advancements in the treatment of diabetes?
Well, there's no question that the insulin injections saved lives and have been durable. The Canadian discovery for, as you mentioned, 101 years, and those treatments have got better over time. Better ways to deliver insulin. In the early days, people were sharpening their own needles and using glass syringes, boiling them on the kitchen stove. It would have been fairly horrendous, and insulins were not very good in those days. So there's been a lot of progress in medical aspects of management of diabetes, particularly in monitoring of blood sugar. When I was a medical student, you couldn't measure blood sugar. You have to measure it in a test tube by, boiling different reagents. And then these machines came on that were portable for being able to measure blood sugar on a drop of blood. And that was incredible. And now, of course, we have these continuous glucose meters. A patient wears them, and you can watch moment to moment on the graph exactly what the blood sugar is doing. So there have been terrific advances over the course of time, but it's not enough.
It's not enough. And you haven't touched upon your islet cell transplants, moving right into the stem cell. And we will get into that. But I do have to, are you seeing some of the comments that are coming here? This is a good one. It's just a bone, because you mentioned that you're like a dog with a bone when it comes to your research. The woohoo, Dr. Shapiro. Alexa says, we love you, doctor. You will save all our children from this nightmare. Here's a comment. This is, thank you for your work and your dedication, Dr. Shapiro. So it goes on and on and on. So I alluded to your research. So you talked about insulin and some of the amazing advances in the early years. Now, for those people who may not be familiar with your research, it's complicated, but take us back to when you first began with the islet cells and how your research moved forward. I think when I look at it, very quickly, it progressed. So tell us more about it.
22 years ago, people didn't believe in the concept of cell transplant for diabetes. People had tried it. It just didn't work. It wasn't durable. People gave up. There wasn't funding for it. Nobody. It was a last-ditch effort. And they gave this program to me as a young surgeon here at the university, because really nobody else wanted it at the time, and it hadn't been particularly successful. And so, the Edmonton Protocol came out of a last-ditch effort to try to make these cells work. And my thinking at the time was, can we put in enough cells? Can we use anti-rejection drugs that perhaps hadn't been used in the same combinations previously to keep the cells alive? Could we get rid of the steroids that were so harmful to the function and survival of the islet cells that make insulin? And when we did that, our first 7 patients, every single one of them came off insulin and stayed off insulin for over a year. When we first wrote our paper in the New England Journal, and you and I first met in the year 2000, it blew people away, and it of course blew us away, because we weren't expecting those kind of results so early. And it's been durable. This year we celebrated 20 years of the Edmonton Protocol, and we published a 20-year outcome paper in one of the Lancet journals. We're very proud of that.
Wow.
That's a 20-year outcome, 400 odd patients in that trial. And we've got really robust data showing how successful that treatment not only in the first year, but over 20 years. So it's been a very, I think, important advance, emphasizing the possibility in the future potential of cell replacement therapy, cell transplantation for the treatment and potential cure of diabetes.
I just want to hop in and ask a question, because for those people listening, when you hear about the islet cell transplant and people being off their insulin, the logical question that I asked many years ago was, why is this not considered a cure? And your answer was?
Well, my answer was then, and it's still the same now. A cure means that we can deliver a treatment across the board to children and adults to have minimal risk and to be able to put diabetes behind you. And with the Edmonton Protocol treatment, it's a remarkable advance. It allows incredibly stable blood sugar controls, and many patients can stay off insulin for periods of time, sometimes over 20 years, sometimes shorter times. But patients have to take anti-rejection drugs, and those powerful anti-rejection drugs have side effects on the kidney, side effects in terms of increasing risk of infections, and side effects in terms of increasing potential risk of cancers. So you're exchanging essentially one treatment, insulin, for another treatment, a cell transplant, plus these other potential side effects that when you need those drugs to save a life, like in a heart or a liver or lung transplant, it makes complete sense. If you have an alternative treatment, which is insulin, it may not make perfect sense for a child just diagnosed for diabetes. So if we could move that treatment forward, not be reliant on these scarce organ donors that we're never going to have enough to go around for the 450 million people that you mentioned, Carrie, and if we could do that and carry out a transplant with minimal or no anti-rejection drugs, I think we would move this incredible treatment to a cure.
Which you have done, and you've started trials in that. So tell us about the latest updates and the work you were doing with stem cells.
Okay, so you mentioned our first Canadian attempt at a stem cell transplant eight years ago in collaboration with a company called ViaCyte, and we've continued trials with ViaCyte ever since. Last year in December, we published our findings where about a third of the patients having the transplants under the skin, in this case, inside little devices, receiving the stem cell islets, a third of them had detectable insulin measurable in the bloodstream at different points in time. So that was a first demonstration that these stem cell transplants could indeed act in a similar kind of way that an islet cell transplant can. Not quite as perfectly when you put them under the skin, but clearly an advance.
For anyone who doesn't understand what stem cells are, describe what they are and why they're so valuable in your research.
Okay, well, we're all made essentially from stem cells. You know, we began as an egg and a sperm, and that we grew into a blastocyst, and we were a tiny, five-day-old tiny little ball of cells. And those cells grew, and they were called differentiated, which means that some turned into your fingers and your ears and your eyes, your nose, and in some cases the pancreas and the cells inside the pancreas called the islets that make insulin. So it takes 27 days inside an embryo for the insulin-producing cells to be made. Now, a stem cell can be taken either from an embryo, like that 5-day-old ball of cells, which is what ViaCyte did with their PECO1 cells that we've treated patients with. And then the other approach is to take adult cells, not requiring an embryo, and then turn them back in time. And this is possible now because of the advances of a Nobel Prize-winning scientist, Shinya Yamanaka. He was able to take adult skin cells, add some different reagents, viruses to them essentially, and basically turn on the original cells like they would be, so pretend they're inside an embryo. And then what we can do with those kind of cells is make them think that they're inside the embryo and add different growth factors at different times. And that's what you're going to learn from the lab team in a minute. And what we're doing there is creating that 27-day period that those cells are differentiating or becoming the islet cells that we want them to be. So we're coaxing them along and making them think they're inside the pancreas. A bit sneaky, if you like, but it's
brilliant. It's absolutely brilliant. Vincent asks right there, where are they harvesting these stem cells from?
Okay, well, stem cells can be taken from different sources. I mentioned the embryonic cells, so from a single embryo from an IVF clinic that was discarded back in the 2000s from ViaCyte. And what we're trying to do now is avoid those ethical challenges with the embryonic side and take patients' own stem cells from the blood. So we take a blood sample, a tube of blood, and then we separate the white cells inside the blood, and then we add these Yamanaka factors, they're called, that the Nobel scientists discovered. We turn those cells back in time, and then we add those growth factors. So the answer to the question is they come from the blood, a blood sample.
But in order to do this type of work, last year when we were talking, you talked about incubators, that you envision a lab with walls of incubators. So paint a picture with your words, Dr. Shapiro, of where this funding would go to, what this would look like, and how you could do multiple transplants with these stem cells.
Okay, well, you mentioned funding there. So, I'm always peering over the cliff edge in terms of research dollars. This is incredibly expensive work, and I know it's incredibly ambitious. We wouldn't be working on it if we didn't think we could get to the end, but it is ambitious, and it scares me how much the research costs and these reagents and growth factors cost every day. But take you to the vision of it, as we move this forward, we're making cells from patients' blood, patients' own cells. Now, the beauty of that, if it comes from you, your body's going to accept it and not treat it like an organ transplant and reject it. Now, we still have to deal with the autoimmune process, which is a part of the immune system with patients with type 1 diabetes. We won't have to contend with that for patients with type 2 diabetes, which is, of course, the vast majority of patients with diabetes. And what we're trying to do is make patients' own cells, one at a time, in mini little incubators, make enough to make more than enough to transplant the same number of cells, if not more, that a normal person would have. And then do this thousands upon thousands of times eventually using robots perhaps to assist us, machines, machine learning. We're dealing with experts in machine learning now to see if we can scale this process up and simplify it so that we can eventually reach a point where perhaps not us, perhaps it'll be more industry at that point, we'll be treating millions of patients with diabetes with a single treatment, patient's own cells, and not needing any insulin. That would be the vision I would have. And you can imagine this massive lab with mini incubators, like each the size and shape perhaps of a bread machine, fully automated, perhaps robots adding chemicals and different reagents at different time points, taking samples, robotically analyzing the imaging under the microscope, helping us pick the right clones for growing the cells. So this is absolutely possible. It might be futuristic today, but we have to look in the long game to how things are going to look 10, 20 years from now. That's how it's going to look.
I love that you are doing that, and I can see it as clear as day. It kind of, and not to, but have you seen the movie Avatar? Where they had the wall of all the incubators, but the wall was filled with humans in the incubators, and they were going into time. That's what I see. So, I love the analogy of the incubators and the robots doing it. I mean, artificial intelligence, we have to move into that space if we're going to do this en masse. So I love that you are thinking that way. I can ask questions all day, but we have some great questions coming in from our audience right now, and I want to go to a few of them. Here's one from Mateo. This is interesting. He says, our single and only concern is red tape and political challenges. How do you foresee the challenges that will stem from the FDA or Health Canada? And how can we as a community make a difference in this?
Well, fortunately, we're in Canada, so I only have to deal with Health Canada. And I have to say that it's been a privilege and a real pleasure to work with Health Canada. I mean, you're going to talk to our research team, some of the team members that are directly interfacing with Health Canada on a daily basis. They have been, I would say, very supportive of this advance in technology. They've been very understanding. They've asked very poignant and appropriate questions, but they haven't blocked our ability to move forward. The example is, 8 years ago with these new stem cells, when we sent them the package originally, it was the size of 2 telephone directories. It was a massive project for Health Canada to take on, and when they analyze a project or a protocol, they're supposed to do it all in a month, and then give you an answer: yes, good to go, or no, not good to go. So the very first time we sent that in, they came back to us and said, we've never seen anything quite like this before. We need a bit more than a month to digest it. Would that be okay? And we said, of course, take as long as you need to ask the right questions and make us, get the protocol right. And I think the month later, that very first protocol was approved, and they have been, I think, very enabling of research and not obstructing in any way so far. And there will be challenges ahead, I think, as we move forward with these stem cells, and particularly when we're making personalized stem cells. In other words, not taking a massive bank of cells, validating them and treating millions of patients with that same bank of cells. But when we're taking patients' own cells, and every single time going through that process, I think we will have to develop some kind of understanding with Health Canada and the regulatory agencies, how they can appropriately regulate and ensure that good standards are maintained throughout the manufacture. And so there will be challenges ahead for sure. But I would say that we don't really have political challenges there. And overall, they've been very enabling.
Great question. Thank you for asking that, and thank you for digging into it. Talking about islet cells and stem cells, here's a great question too. Would your immune system not attack the new islet stem cells the same way it attacked the original islet cells?
Well, it might, and that is our concern, and that is a question that we've been working on intensively in the lab over the course of time, and in clinical trials too. So, for example, we've had a clinical trial where we've been resetting the immune system with a very mild treatment of anti-inflammatory agents that we give basically once at the start of treatment, and then we follow patients through with the other anti-inflammatory medications for a couple of years afterwards. And what we found there is that we can control the autoimmune response in a fairly simple way. And I would hope that by combining the advances in the patient's own stem cells with that kind of approach, that we will be able to, what I call, attenuate the autoimmune attack systems so that they won't destroy those new cells. But in truth, we're going to have to test that in patients, and one after the other, find out if our hypotheses are correct and if we really can do that. And I'm sure that will be an iterative process, meaning that we'll try something once or twice, and if it doesn't work, we'll make adjustments and keep refining it until we get to a point where it really is successful. That's how research goes.
It does. Thank you for that perspective on that question. Here's a nice comment. It says from Gary Brown, I remember studying and doing a bit of STEM culture back in the 80s. None of us ever considered where you and others have taken it to revert RBCs and grow beta cells. Just blows my mind. That's got to feel good to hear that.
Yeah, it's if you told me about this 20 years ago, I'd say you're balmy. It's crazy. It's never going to happen. It's unrealistic. But I think that, advances happen in science, and sometimes it feels like when you're at the front end of it, it's very glacial. Things happen incredibly slowly. It's not like you look out the window and yesterday it's summer and today it's winter in the snow. But research doesn't necessarily happen like that. It happens in maybe the odd jerks, but yeah, if you take the long perspective and you look back and you look where we are now, when I was learning about stem cells in medical school, we were making diagrams of the stem cell, and then they come in the white cell, the red cell, and all the things they made. We never imagined that we'd be making islet cells. Who would have imagined that you could add a few chemicals and over 27 days turn a blood cell into an islet cell? Well, you really can, and you can potentially cure diabetes with our approach. There's no question about it. We've done this multiple times now in the lab. The data shows that we can do it. We've still got lots of challenges ahead, but it is going to happen.
Here's another great question from Gary Brown. Will the anti-rejection issue involve an epigenetic answer? Possibly.
Well, it might. That's epigenetics are certainly complex, and we're talking about the cells and maybe the mitochondria and other processes inside the cell that can regulate and control immune attacks. So it might be an epigenetic as well as a nuclear kind of phenomenon.
Okay. So many great questions coming in, but I also know, and I'm watching the time, that we have your clinical team and your research team with us tonight, which is so huge. They've already had a big day in the lab. They all stayed behind tonight. And what I love, Dr. Shapiro, is every time that I have interviewed you or talked to you, no matter the occasion, you always push the praise towards your team. You're so humble that way that you say, my team, my team, my team. And tonight was very important when you were talking about your research, that you bring your team into this broadcast and introduce them. So what we're going to do is venture right into the lab, and you are going to help me interview every member so they can say hello and we can find out what they are doing. So let's venture into and say hello to the clinical research team.
Okay,
hi, everybody.
Right.
Hello. Hi.
Okay, so you've got Diney, you've got Sarah, and you've got Raina, and we were talking about moving clinical trials forward, and we were talking about Health Canada. So Raina, why don't you come up a little bit closer to the screen for a second, and tell us, you're the person, I guess, that interfaces most with the regulatory side of the program. People have no idea what we've done. How many clinical trials? About 30 different clinical trials over the years. And, I come up with an idea maybe, or we come up with a collaboration with industry, and then I throw it at the team and throw it particularly at Raina to take it through Health Canada and the approvals. And she makes my life incredibly easy by dealing with all the regulatory headaches, the things that I wouldn't have the patience for in everyday life. So Raina, tell us a little bit about what you do, what the challenges are, and what it's like from your perspective.
Thank you very much, Dr. Shapiro. Great to be here. My name is Raina Bachniva. I am a registered nurse. I am a certified clinical research professional. I am also certified clinical research monitor. I have been working for the clinical islet transplant program more than 10 years, and my responsibility related to research have been always towards successful clinical trials. What does it mean? It means like I'm ensuring that our clinical trials are conducted according to the scientifically sound research protocol that has been approved by Health Canada, by University of Alberta Ethics Committee.
Raina, why is this work so important to you?
It's so important to me because I need to first, in order to be able to enroll participants in a study, I need to have on place Health Canada approval, ethics approval, stem cells committee approval, approval from Alberta Health Services related to our research activities. I need to have in place also related to our research contracts that have been fully executed and in place. In addition, related to my activities, I'm ensuring that our clinical trials are patient-oriented.
Okay.
That means that patients' right, patients' safety, patients' well-being, and patient confidentiality are our most important considerations.
That is so wonderful. I know everyone is enjoying hearing that they are the number one focus.
Raina's an absolute stickler for the rules, and
is she? You need someone like that,
and we need somebody has to do that. You know, we can come up with all the craziness, but at the end of the day, we need to be able to. You know, every patient has to have a consent when we move forward in the trial. Those have to be filed in a certain place. Raina knows where everything is for every patient and every trial, and without her, we couldn't do what we do.
Raina, thank you for all you do and for joining us tonight. Before we introduce our next person on the team, a couple more questions here, Dr. Shapiro. Gabriella wants to know, have you done trials on children yet?
Well, we haven't, and it's not that we don't want to. We do, but as most trials move forward, the very first patients that we expose have to be people, and at least in my opinion, have to be people that can truly understand the potential risks involved. And the very first patients, often in a trial, we have no idea what the outcomes are going to be. So it seems important to me that we have well-informed patients moving forward. And as soon as we think something is safe enough to move forward to a child, we wouldn't hesitate to do that. But I think we're still in the point with a lot of the trials, particularly on stem cells, where we're focusing on adults first, really for proof of concept and demonstration of safety. And as soon as we've got that, we'll move it as fast as we can into children.
Yeah, lots of questions in that regard. So that answers a lot here. And Azar says, good work, research team. Even you guys are getting the love here in our comments. So Dr. Shapiro, go ahead and continue with your introductions.
Well, Syra, why don't you tell us what you do in your daily work?
So I'm a research coordinator with the clinical research team. We do study startup, patient recruitment, screening, study budgets, patient visits, their follow-ups, and data collection and maintenance.
So this is sort of implementing the clinical trial these protocols. I mentioned they're sometimes the size of a telephone directory. They're very complex, and we have to make sure that every patient that's enrolled fulfills all the criteria for being an approved patient and doesn't have any what we call contraindications to the trial. And as we move forward, if anything happens that we didn't expect, it's very important that all those things are very accurately and in real time documented for safety. And that's sort of what Sarah's doing.
Sarah, do you have a chance then to talk to patients?
Yes. Yeah.
So what is their reaction when they get chosen to be part of the trial? What are you hearing about this work from them?
Most of them are very excited and very grateful to be part of it, which is nice. It's nice to hear.
It must be. That's got to be a rewarding part of your job. And for you personally, why do you feel drawn to this type of work and why are you connected to it?
A lot of times hearing stories from patients, it's really nice. Like for them, it's like hope, right?
Mm-hmm. Well, thank you for all the work that you are doing. You must be, are you a stickler for the rules too?
We have to be, right?
We appreciate you joining us.
Yeah, and then we welcomed Diney, and Diney's. Well, I'd like to say she's an expert and a jack of all trades. So Diney first got involved with us. Diney, why don't you tell us what your first job was when you and I first met?
Yeah, first time I met Dr. Shapiro, I started
We've got no sound, Diney. I don't
Yeah,
know why.
Diney, get a little closer to the mic there if you can.
Okay. Can you hear me better now?
A bit closer.
Come right in because it's quite quiet.
Okay.
There, yes.
Oh, I'm here.
Okay, good.
So first I started with Dr. Shapiro working in the ex vivo liver perfusion project. So we have a machine and we put a donor liver and we perfuse it with blood, and then we transplant it to patients. And that's an awesome technology. And I'm still working in that project, and it's awesome. And that's how I got involved. Then I moved over to islet transplant, and I have been working islet transplant coordinator, and it's been amazing.
What makes it amazing? Because you've been at this for a few years. Is progress slow in your eyes, or is that just research? Can you give us some perspective with that?
The projects are evolving, I will say, faster. Like I got involved in the program 5 years ago, but in islet transplant I got involved less than a year ago. But I have been hearing all the progress and everything is been going on, and it's amazing. It's amazing, and everything is happening because this great team.
So but during the night, every night we did a liver transplant. Diney would be up all night running this machine, and she did such an incredible job with that. I mean, I'd stayed up for the first one or two, but I couldn't do that and then do the surgery. I needed somebody else to help out. So she did an amazing job with that, and then she's continued to do an amazing job with the islet cell research, finding patients, helping follow protocols. It couldn't happen. Research couldn't. It doesn't happen with me. You know, maybe begin with an idea, but putting those ideas into practice involves an incredible professional team, and that's what some of the members that you're meeting tonight.
Here's a question for both of you. This is a great one. We are looking forward to having a cure in Turkey and Azerbaijan. Can the trials be conducted in the clinics beyond Canada or in the United States?
Yeah, there are trials moving forward in multiple different countries. For me, my focus is to make things happen locally, because it means that I can follow the patients regularly for safety and outcome and adverse events, and I can keep a very close eye on them. So as we first begin new treatments, we begin locally. But now if you look at the Edmonton protocol 22 years later, there's 40 different centers practicing that or have practiced it across the world. So we've helped others deliver that treatment and make it more successful. And in some ways, their research has helped ours too, because we've learned from, the experience that others have added to this. So there's no reason why this can't happen in other countries, such as Turkey, Azerbaijan, and other countries. We're fully supportive of that. We're fully open to it, and we want it to happen there too.
It's exciting that it's starting, like you said, that you can take it around the globe. All right, clinical research team, thank you all so much for joining us and sharing what you do tonight. It's been a long day for all of you, and we appreciate you weighing in and sharing your enthusiasm. That's what I loved hearing from each of you, to explain really how detailed your work is, but how committed you are, of course, but how excited you are to be part of this journey. And that is really, it's heartwarming to see that you all pour your hearts and souls into this and say that, wow, it sounds like it's a gift to be on this team. Am I reading that correctly?
You're absolutely right. Yeah.
All right. Thank you all so much for joining us.
Sorry we kept you in.
Thank you. Thank you very much.
Thank you for all you do.
Wow, what a team. And that's not easy, I have to say, taking that work and really breaking it down so the rest of us can relate to it. Let's continue on. I know that we're going to bring in our rock star from last year, shall we? Nadish?
Let's do it. Yeah, let's do it.
He was the one that took us on the tour of the lab with the laptop in hand. How are you, Nadish?
I'm very well. Thank you, Carrie. Thanks for having me here.
Oh, it is such a pleasure to have you. And you're not in the lab tonight because you're sick right now, like a lot of people are. So that's the way life is. It's the way it goes. But we wanted to have you a part of our broadcast as well.
That is correct. Yes, thank you.
So tell us a bit more about the work that you are doing with Dr. Shapiro and why you're so committed to this path.
So it's a pleasure to be back again this year, and it was a very exciting year. We finished 20 years of our Edmonton Protocol anniversary, and still going on. From the last year, we have started this exciting journey for translating stem cell-based therapy into clinic, and we have been working so hard to take this to the clinic as soon as possible. We have been working extensively hard in defining our method and technology so that these cells can be the most safest cells into the patients before they go in.
Okay, so I have some questions as you were talking, and there's already a lot of people saying thank you, great team. Thank you to the team. Okay, here's one from Vincent. What besides mice has clinical trials been used on? Because mice have two different types of insulin, so that research doesn't translate to humans very well. Do either one of you want to comment on that?
Well, maybe I'll take it. We do use mice for certain studies to learn things, but we know it's an imperfect model. We know that the best models are patients that have type 1 or type 2 diabetes. So, we learn a lot from mice. We can test basic concepts there, but it's a different kind of diabetes. If we make an artificial diabetes model in a mouse, it's not the same as an autoimmune diabetes in a patient. So we can learn something from mice, but not enough to take it forward. That's why a lot of our experiments are moved from mice to people quite quickly, so that we can learn in the real world what impact we're having in this disease.
Okay. Thank you, Dr. Shapiro. Nadish, you have some fans on here. It says Nadish is the best. He said last year, we are close to saying that diabetes is history or that diabetes is a disease of the past. Do you want to comment on that?
Yes, absolutely. This is the vision. This is the most important thing that we started our journey with Dr. Shapiro a couple of years ago, and I think this is what we want to make, and we will make it very soon.
Thank you for saying that, because in that spirit, Gabriella says it must be amazing to be surrounded by people and patients who are so full of hope and joy. I love meeting people who truly believe in this. It's so passionate for the type 1 families around the world. Isn't that beautiful to hear that? Because they're listening tonight and they see the hope in you.
It is indeed. I completely agree. We are passionate for our patients, and we understand their clinical conditions. And I interact with many patients in my office, and as a part of this research, I recruit patients, and so I totally understand where are they coming from. And believe me or not, but truly, I do want this thing to happen as quickly as possible, so our patients get free from insulin, free from diabetes forever for their lifetime.
Here is Mona Lisa saying, I am a living example, currently off of insulin since 2016, thanks to Dr. Shapiro and his team. Life-changing. I am so thankful. It's got to feel good to hear those comments.
Yes, it is.
Here's one more. This is a good question, Nadish, and then I'll let you go. My 32-year-old son was diagnosed a year ago with type 1. I, too, have my youngest daughter's cord blood stored. She is my son's half-sister. Is that a source for the transplant for him?
So I would say that the type of therapy that we are working on is called autologous or cell cells. So we believe that taking a cell source from patient's own body is the most meaningful cells that can be used for their treatment strategy. If it's from some other person, there are other layer of complications that we need to look after, and can be considered for utilizing islet cell as a product. But at the moment, we're focusing on self cells, which means patient's own cells can be taken, can be made into islet cells, and can be put back into the patient's body.
Dr. Shapiro, you and Nadish had been side by side for a number of years, haven't you?
Yeah, I'm actually thinking back to when Nadish and I first interviewed Nadish. It was in the middle of a crazy liver transplant clinic, and I found the smallest room in the clinic that I was working on typing charts, and somehow we managed to squeeze a second chair in there. And he and I were chatting, and I said, "I'm sorry, it's such a crazy day, but come on, do you want to cure diabetes with me, and make stem cell islets?" And he immediately jumped at it. He said, "Yeah, I think I've got all the skills to do that. Let's do it." And that's how that began.
Wow.
And we haven't looked back. And I have to say, despite the fact that sometimes it feels frustrating on a day-to-day basis that we're not making progress quite fast enough, when I look where we were at the beginning with nothing, basically, now we've got this beautiful stem cell lab, and we're able to make these human islets from stem cells fairly reliably. I think we've come on an awful long way in lightning speed. So I know I'm always, cracking the whip and saying we're not going fast enough, but we have actually made lightning progress in a fairly short space of time.
You have, from all of us who are watching what you're doing and cheering you on from the sidelines, you have. And that's why nights like tonight are so important, to talk about the advances and to highlight them, to show the progress over the years. Well, Nadish, thank you so much for joining us once again, and for sharing your insights and your perspective. I'm so glad that you and Dr. Shapiro work side by side in this, and I look forward to connecting you on many more future broadcasts.
Likewise, thank you, Kerry, for having me over here tonight, and thank you, Dr. Shapiro, for supporting for everything, single thing in this journey. Thank you.
No, thanks, Nadish. Couldn't do it without you.
Amazing. He is, I love that story that you had to jam into a tiny room. And
it really was. It was crazy when I think about it.
Oh, great story. Thank you for sharing that. Where do you want to go next? Do you want to go talk with Isla?
We should go to Isla and Rena and have a quick look in the lab that Nadish works in every day.
Okay, into the lab we go, everybody. Look at that.
Hello.
Rena and Isla. So Rena and I, Rena is our chief technician. Rena, how long have we worked together, dare I say?
20 years, over 20 years now.
Yeah.
We've worked together, so yes.
This is where it all begins. So with Rena in the lab, we come up with a crazy idea and we begin to test it in mice. We build experiments that will prove or disprove the idea. And Rena acts as the sieve, basically, proving whether something will work or rejecting it and say, no, it doesn't work. And she's helped countless students, graduate students, PhD students get through their PhDs so successfully. Our last PhD student, Braulio, just got a big prize, a gold medal for his work. So we're absolutely thrilled about that. And Rena's helped all along the way. So I've been very, very fortunate in having Rena to work with so closely over so many years. And she, again, makes all of these people you're meeting tonight make my life easy. I can sit in the rocking chair at home while things really happen in the lab, and the hard work is done by Rena and the team.
Rena, honestly, like when Dr. Shapiro tells you, like, I want you to test this, do you ever think that, wow, this is a wild and crazy idea?
Yes. That's the easiest answer tonight. The easiest question you gave me to answer tonight. Often.
Okay, so
but no, I enjoy that too, because a lot of investigators won't take that initiative, and he will try anything to see, can we see if it works, can we get it to work, etc. So that goes a long way into innovation and trying new things and working through problems, and that's what we have to do.
So where you are tonight, is this your lab where you live every single day? Can you show us a little bit of it?
Yeah.
I know Nadish showed us last year. Go ahead.
Certainly, I'll just switch around here. And Dr. Ila Jajwa is going to show you a few things. Can you see into the lab here?
Yeah, we can. Yes. Yeah, okay, Rena.
Okay.
Great.
Yeah. So go ahead. So
yeah, this is the incubator where we keep our mini islets, and you can see these are the clusters which are derived from type 1 diabetic patients, and they are in a vertical wheel bioreactor. As you can see, these small structures which are growing, and these are settling down because I have removed from the base. So these are the islets. Now,
So just to be clear, just to emphasize that, those tiny little white dots that you could see in the pink fluid there, going round and round and round now in the circuit that Ela just held up, those are what make insulin. Those are what can cure diabetes. Those are the patient's own cells made from patient's blood. And we want to get to the point where we can transplant those back into the same patient without anti-rejection drugs. Those are the islets that we've made from stem cells.
That's the magic.
Now
wow.
here you can see these islets are stained with ditizone, that is a red color dye, in which shows that these are positive for this ditizone, and this also indicates that we are getting like beta cells in our differentiation preps. So now Rena, as you can see here, we have played our clusters in a petri dish, and we can see like how these are with a detailed stain. And now Rena is going to show you the different way of staining these clusters, that is islets.
This is so, I'm putting up comments as you're taking us on the tour because everyone's saying, amazing, this is so cool. And they want to see more white dots.
So these are some stage 6. So they're at the end of their stage of differentiation. And we stain them with different immunohistochemistry markers. For insulin is in the first slide here. And then you'll see glucagon is stained yellow, somatostatin and chromogranin A. So these are all markers that we can see that these are producing insulin. These beta cells that have been basically differentiated from human patient blood samples.
That also shows how complex an islet is. It's not just a cell that makes insulin. It makes an orchestra of different hormones. And what we have to do as we make these in the lab is make sure that they look and behave exactly the way a healthy human islet would. And that's what Rena's showing you there.
And that's also explains to us when we see all of these little examples, and this is just like we're barely scratching the surface here, why it takes time to move forward with research and science and projects like this. Like, it's so detail oriented. This really drives that message home. Right, Dr. Shapiro?
Absolutely, yeah. I was going to let Rena answer that.
Oh, sorry.
Yeah.
You want to tackle that? There's a lot of steps.
I told you we're near.
There are a lot of
There
are a lot of steps, and Ela has been in the biosafety cabinet for pretty much the whole day. Go ahead.
Yeah, I mean, like these cells, like literally takes lots of time, first of all, to expand, then go for the scale up, and then final for the differentiation. So before I start or we start as a team differentiation, there's a huge process which we have to do prior hand before we start with the differentiation into beta cells. That is a 27 days process, which includes like 6 stages of differentiation. So it takes a time to get into that stage without any issues in between.
We're basically growing these little babies from the beginning to the end, but we have to feed them different nutrients every day along the process. So that's where they get all their growth factors, etc. Is their daily media changes.
Even on the weekends.
And
it's like baking, following a recipe.
Wow.
But you have to follow this one incredibly precisely. And if you don't get the cells fed with the right growth factor at the right time, everything goes wrong. You got to start from scratch again. So it's incredibly demanding on the team. And I'm so very grateful that you can see they come in at the weekends. They work incredibly hard make this happen, and it wouldn't happen without that.
How do you feel to be part of this research, both of you?
I feel incredibly amazing, such an exciting team and such an exciting project. Like I joined Dr. Shapiro last year in 2021 in the middle of the pandemic, and it's a great experience, and working towards the cure, working towards the bigger vision to get to the cure for the treatment of type 1 diabetes. So it's amazing to work with Dr. Shapiro and the team.
Rena, just show us the machine behind you for one tiny second. So that machine, there's a label on it. It's Hutton Roberts. So that boy was 11 years old. He is 11 years old, and he walked around London in England, around every single park in London during his half-term break at school, and he raised the money to buy that machine, which is a very fancy flow cytometer that measures and stains the cells. We use that machine every day. So that's an example of why we need research dollars and how it can make a massive difference to what we do every day. And we need a whole load different kind of machines, just like that one, just like that incredible gift from an 11-year-old boy
That's
who has
unbelievable.
diabetes. And we're so grateful to everybody that supports us, and particularly to DRIFCan for making this happen. This is where your money goes every day.
You can see it firsthand. Ladies, thank you so much for taking us on such a brilliant tour and for sharing your passion and your work with us. We appreciate you both so much.
Thanks, Rena. Thanks,
Thank you so much. Thanks a lot. Thank you.
Wow. Look at this from Dorothy Nelson says, bless you for showing us up close to see how this work is evolving. And that's what's so cool about going into these labs and talking to your team, Dr. Shapiro. We have a couple more that we need to get to before we wrap up tonight. So who would you like to talk to next?
Who haven't we talked to?
Heidi, I believe.
Heidi, yeah, come on, Heidi.
Pardon me. Hi, Heidi. Yeah. Sorry about that. Hi, thanks for waiting. Are you enjoying this whole conversation?
Absolutely. I find it very fascinating, and this is great because I think it was about 13 years ago or more, I was working with Dr. Colin Anderson, who he was working on immunology and tolerance, and we shared lab meetings with Dr. Shapiro and his team. So while we were more on the science side, asking how natural innate tolerance works. Dr. Shapiro was very interested in our research, how we could apply it to his work on islet cell transplantation. So I know Dr. Shapiro for many years. Of course, due to the nature of my job, I had to switch labs, and I actually went to the States for a couple of years. But when I came back, I had this great opportunity of working directly with Dr. Shapiro and his wonderful team again. And so I've been back, and it's been a year now, and I've been learning. It's just incredible how much I've been learning. And so basically my job here is I am the research technician in the stem cell diabetes lab, and I support the amazing group of grad students, postdocs, and our amazing senior research lead, Dr. Dedich, in helping create these personalized beta cells from these iPSCs, or inducible pluripotent stem cells. So what I do is I prepare the growth factors and the reagents at the proper concentrations and temperatures and have them ready. So when the team needs to use them for their cell development, they'll be ready to use right away. And I also organize the lab to make everything run more efficiently, making sure everything is ready for them. And so that's just one of the many roles that I'm playing. But I just started recently, and it's just amazing how much I'm learning. Very happy to be here.
Heidi, we're so lucky to have poached you.
That's a good way of putting it.
Yeah,
technical, but so important. So important. Here's $1 million question. How much money do we need to raise to have a cure in the next 3 years?
Yeah, well, I mentioned that cliff edge that I keep peering over, and I can't really show you exactly. The the burn rate in the lab for these experimental approaches is massive. And to take this across the finish line, to really prove that we can make patients' own stem cells and show that they work in the first 12 patients or so, I probably need another $5 or $6 million, and then to move it forward to where we're ready to sort of get industry involved and hand it over to industry, we probably need another 10 million. So, that gives you some sense as to what we really need. And we know that these fundraising organizations such as DRIFCan do a phenomenal job, and we couldn't do this without them. But we also know that we sometimes are stretching the fundraising to the limits of what's possible. So anything that we can have in the way of donations really helps accelerate this work. I just want maybe to leave that message with you tonight.
Heidi, thank you so much for joining us and sharing
Thanks,
your
Heidi.
passion with us. We appreciate all you are doing. And before we bring in our final person with us tonight, I'm going to remind everyone that you can still make a donation tonight. DRIFCan.com is where you can do that. And in any denomination, we have people joining us from around the world. So if you're in the United States, you can do it in USD. No matter where you are, you can make it in the currency of the country that you live in. So, and you can continue to do that. Just because we might end our broadcast in the next 5 minutes doesn't mean that you not have time to do it. Go to the website, and as Melanie mentioned a little bit earlier, there's a variety of ways that will be outlined in how you can make a donation. Not just money, there's other ways as well. Dr. Shapiro, one more person to go. She's been waiting so patiently and listening.
Yeah, so Nuria, tell us what you do. Maybe we should say first, how did we find you?
Well, I was doing my PhD in Glasgow in the United Kingdom, and I was collaborating with Serene Forbes, who is based in Edinburgh. She's also a diabetes researcher. I was collaborating with her, but then COVID hit. I'm immunocompromised, so my boss literally kicked me out from the lab because I was a high risk. So I couldn't continue working with Serene. I was still doing my research in Glasgow. Well, back on the day, I was writing my thesis from home. So I was really keen on working with diabetes. I have a molecular biology background, but I did my PhD in immunology and stem cells. I have an autoimmune disorder. I've been immunocompromised for the last 5 years. And while there is no stem cell related cure for my disease, there is stem cell related cure for diabetes. And that's why I was so eager on working with stem cells and trying to differentiate them towards beta cells. So even if it was across the world, I contacted James and I was like, hey, I'm super interested in working with the differentiation. I really want to make a change. So we arranged an interview. It took a few months to arrange my visa because of the pandemic, obviously. And I finally joined the lab in April 2021. As James has said, like the process of differentiation is really intense. There are 6 stages. In each of these stages, the cells require different foods so they can grow in the way we want them to grow. Throughout all those stages, we need to be very thorough studying their behavior. Are the cells really going from stem cells into pancreas? Within the pancreas, are they making beta cells or are they making other types of cells? So my work in the lab is mostly focusing on characterizing the cells throughout all those stages to make sure that we are making the best islets that we can, and also characterizing the function of the islet. So there is one assay which is really cool. We will put the islets that we generate in low glucose and we will leave them in there for 30 minutes. And we can measure real time how much insulin they are secreting. And then we put them in a high concentration of glucose and we see how they spike, like there is a massive spike on insulin secretion. So all those tests are essential to ensure that the islets that we are generating are safe and are going to work into patients. So yes, I'm very motivated about what we do.
You love your work, don't you?
Yeah, I do. Unfortunately, even if it's too many hours and it's too many weekends, but yeah, I love what we do. So.
Nuria is a star. She's a brilliant scientist. She's made incredible contributions to the process in the lab. We've recently been comparing with her and also Kevin as well, who you haven't met tonight. He's working in the hospital tonight. But they've been looking at the different ways. They call it 2D versus 3D growth of the cells and demonstrating which is better and refining the protocols. We're so lucky to have you, Nuria, and lucky for us, not so lucky for Scotland, but we're so lucky you
Yes.
came here. Yeah.
Lucky for us. Thank you for your patience and for sharing your work and your passion. It's palpable. I love it. We're so grateful you're on the team.
Absolutely. Thank you for having me here.
That was so interesting. I can see Melanie in the virtual green room, and I know it's 7:30, but can I just go along? I mean, it's not like the network's going to cut us off. Yeah, she's saying yes. There's so many questions coming in, Dr. Shapiro. Can I ask you a few of them that are coming in? And I want to make sure that there's so many people that are still watching. So let's honor them. And let's dig into a few of these. I love this comment here. It says, you were talking about the funding, drop in the bucket for the federal government. How can we lobby them to see the value in supporting this research? Your thoughts on that?
Yeah, we do need government funding. It would be a lot easier to get government funding than it would be to raise money through foundations. But we also recognize that governments have to, they fund the infrastructure of every day for our society, and they should invest in things that are delivering. So I think they need the tantalizing proof first that something's going to pay off before they kick in. So there's lots of support. My Canada research chair that supports some of my work is government funded. So I have to acknowledge that there's lots of government funding in research. But for this particular project at this particular time, we don't have enough funding to make it all happen. We're peering over the cliff edge all the time, and we need to make some progress in the funding if we're going to accelerate the cure. So yeah, we'd like more government support, but we can't rely on it right now.
Yes. This comment I just had to put up. True, COVID got all this money. Why not DRIFCan get some government money?
That's true.
Had to acknowledge that. Gabriella says, I know if we had the money, we'd hand it over, no question. This is just funny. Someone write Nick Jonas or some other famous and rich type ones to help out. I mean, it's people are thinking, and let's see what else here. People talking about a lot of their friends and whatnot that they've lost friends because of diabetes. Here, Kathleen Gibson says the passion of the research team. It's just so great to see. Nikki says thank you to the whole team who is working toward a cure. 56 type 1 diabetes for the last 4 years. I'm one of the lucky ones. Here's one that says 58 years, type 1 diabetes, feeling great. I think the research focus is very different for these different diseases. This team is fantastic, and I have great hope finally for a cure for type 1. One of the questions that keep coming up and up and up, so why don't we end here tonight, is how close are you to a cure?
We're tantalizingly close. I can feel it and see it in the data that we generate in the lab, but we're not quite there. We need to know those cells are safe enough to put into a patient, to put in a patient's liver, and know that they're not going to have any off-target growth or concerns. And that's why this work right now this is sort of the hard stage, because we've got a huge amount of work ahead of us, a lot of expense, and we've got to prove in the next year or so, or 2 or 3 years, that these are safe enough to advance to the clinic. And that's our biggest challenge right now. We know we can cure diabetes. We know we can do it in mice. We can make them diabetic. We know that when we transplant them into a patient, it will work. But we have to show that those cells are safe. And that's the big next step for us. And that's why, there's so much hard work ahead of us to get there.
Do you want to venture here? We have 90% there, 95, 85.
I'm looking at those numbers, Claire, but I'm also panicking because my son's at biathlon. He's at age 11, and my wife's working. I've got to go and pick him up in a minute.
Okay.
And if I don't pick him up, I'll be in big trouble. So are we 90% there? I'll tell you when we're there. I don't know if it makes sense to stick a number on it. We're close enough that I think we've shown 20 years worth of islet transplantation that this cell transplant therapy really can work and make a difference for patients. You've heard from some of them tonight on the chat there. We know that treatment isn't perfect. We know that we can make it better. We know that we have one approach in the lab that seems to be working. We're going to move it fast and forward as best as we can, as fast as we can, and make it happen. 90%, give you a number, but we're not. There needs to be 100%. It's got to be.
Yes.
It's got to be there.
I like the sounds of 90. That's serious progress. And I'm going to say on behalf of everybody watching, it has been such a pleasure to spend this last hour and actually hour and 36 minutes with you, Dr. Shapiro, and your research team and your clinical team. So nice to put their, faces to the work and names and to hear what they do. And, one of the many things I will take away tonight is that we are playing the long game. This takes time. And when they started to break down exactly, your team members, what they do and how exact it has to be and how they have to record every last detail of everything they do, it proves that it's time. But then you look at what you've accomplished over the years and it's tremendous progress. And we're getting there. Every day playing the long game is paying off. So on behalf of all of our watchers, behalf of DRIFCan, Dr. Shapiro, my heartfelt gratitude to you and my heartfelt thanks for everything that you and your clinical and your research team are doing to impact and change the lives of patients with diabetes. We appreciate you so much.
It's the other way around, Carrie. Thank you so very much. And thank you to DRIFCan for your support.
Brilliant night. Thank you. I know you have to run. Your son is waiting for you. Yeah. Dr. Shapiro, we love you. We appreciate you. And off he goes, everybody. And I will wrap up with showing all of the comments that are coming in. Thank you to Dr. Shapiro and his clinical team. Thank you, Dr. Shapiro. Heartfelt thank you to you all. It just keeps going and going. Tanya says, thank you so much for this inspiring and hope-filled evening. Jason says, thank you, Dr. Shapiro. Our group will be supporting you until that cure comes. This is funny. Steve Mark says 95% chance you'll be in trouble if you don't pick up your son on time. Oh, this has been such a wonderful evening. And I leave tonight with a bit of that humor. And let me say thank you to all of you for making this conversation as rich as it was tonight. The fact that here is from DRIFCan. I know this is from Melanie. I want to read this. She says, thank you everyone for tuning in and for all of the researchers that came. We are so, so grateful. We truly are. To all of you who joined us tonight on behalf of DRIFCan, for your time, for your contributions that you're making on DRIFCan.com, for never, ever giving up in the hope and the belief that a cure will be found. I've reported on this for well over a quarter of a century. I'm not giving up. Dr. Shapiro is going to find a cure. And one day I'm going to be telling that story. And one day all of you are going to be part of that story because you believed, because you supported, because you came along for the ride with DRIFCan and with Dr. Shapiro and his team. To all of you, thank you for staying strong and staying committed to finding a cure. And thank you so much for sharing your time tonight. For any of you that want to rewatch this broadcast, I know DRIFCan posts it on their website and also on their YouTube. It lives forever on my Facebook page and on YouTube. So let me say thank you once again for joining us, for your support. Never stop believing. Good night, everybody.